Good afternoon, ma'am. Am I
Yeah,
audible, ma'am?
good afternoon. Good afternoon.
Yes, ma'am. Ma'am, few participants are still joining. We'll start within 2 minutes.
Yeah, no problem. No problem.
Thank you.
Thank you for joining today on the Faculty Development Program session number 2. I am Vishal Rao and we are privileged to have Dr. Bhawana Rudra from NIT Karnataka with us. Individual who has academic background with a PhD from Triple IT, followed by MTech from SRM University, Chennai, and the BTech from Jawaharlal Nehru University, Hyderabad in 2000. Studies like domain of crypto, network security, cybersecurity, of things, blockchain security, quantum computing, and many more. Dr. Bhavana Rudra stands out not only for her extensive academic background, but also for her pioneering research in blockchain security. Her numerous and reference publications underscore her commitment to pushing knowledge, from groundbreaking work in quantum error correction to innovative applications of in cybersecurity. Dr. Rudra's contributions have left an today's everlasting mark. Today's session on consensus
Vishal,
unique
you're not audible.
opportunity to explore. Now, am I audible?
Yeah, better than before. Yeah.
Okay.
Yes, Vishal, you are audible.
So, Dr. Rudra's concern have left the start. Today's discussion on algorithms and offers a unique opportunity to explore decentralized systems through the lens of influential experts. Noteworthy hosting projects are the design and implementation of an alarm system. AI. for age accident avoidance in curve-prone areas, energy conservation solutions for sensors in challenging terrains, and automation in hilly areas using sensor-based cameras. With a rich academic background and a trailblazing research, Dr. Bhavana Rudra stands a spotlight in the field of cybersecurity and emerging technologies. So, without any further ado, let's welcome Dr. Bhavana Rudra to enlighten us on the challenge and advancements in the consequences algorithm within the domain of blockchain technology. Your expertise and guidance are sure to be valuable. And now I will hand over the mic to Dr. Bhavana to head over the session.
Yeah, thank you so much, Vishal, for the short intro. Yeah, uh, yeah, thank you. I could able to share. I hope my window is visible, right?
Yes, ma'am. You're visible.
Yes, ma'am.
It's now like a full slide mode. Is it visible? Can you just confirm me whether the change of slides are visible? Change of slides, because I'm in fifth slide right now. Hello?
The list of slides
Hello?
is being shown on the screen.
List
Hello?
of? No,
The
no,
list
not
of
list of
slides
slides.
are shown on the screen.
I've done the slideshow and I'm in fifth slide. Is it visible?
No, ma'am.
Okay, 1 second. I'll do.
No.
I guess that will not work out if I go with slideshow. So is it fine now? Now it is visible, right?
The, the
No,
screen is
ma'am.
not
No,
visible,
ma'am.
ma'am.
1 second. Let me just check it out. Just give me 1 minute. Now, is it visible now? Objectives or consensus? Properties?
Yes,
Yes,
ma'am.
ma'am. It's visible.
Different consensus algorithms?
Objectives of consensus algorithm.
After that, properties, different consensus mechanisms?
No,
No.
ma'am. No.
Okay, then I have to skip the slideshow. I'll just go with normal. Now it is fine, right?
Yes, ma'am.
I'll do one thing. Uh, yeah. So I can't help it out with this. Let me just check it out. No. Okay, now it is visible, right?
Yes, ma'am. It's visible.
The point is, I want to go with the presentation mode, but I'm unable to go. So,
It's visible, ma'am.
okay, then I'll start the session then. Okay.
Yes, yes, yes.
Yeah. Thank you, Vishal, for the short intro. Uh, so let us start with the consensus algorithm. Before moving to the consensus algorithm, I would like to have a small discussion about why we require some consensus. What do you mean by consensus? So, what do you mean by consensus? Leave about blockchain, leave about the set of things and all. But the basic thing is, what do you mean by consensus? I know I'm starting from the basic level, but actually, when we go, I mean, there are EC people, OT people, as of my understanding. So, for everyone, it has to get. So, for that reason, I'm just going with it. Just give me a minute. Uh, Yeah, sorry for the disturbance. So what do you mean by consensus? It's an agreement among all the nodes who are going to involve in some kind of transactions or in some kind of communication, that you agree, I agree, okay, we will use only this kind of algorithm in order to finish our entire transaction to reach to the target level. So that is the general agreement we say. When we go to purchase property, also we'll go with agreements, right? That also we can say as a consensus. So consensus is nothing but a general agreement. The consensus algorithm is nothing but the what kind of agreement we are going to have with respect to what kind of application in the network when we are using, when we are adopting the blockchain technology. So this is what the overall summary of today's session. So that we will see in detail how and what are the requirements in order to achieve to this consensus, what kind of algorithm suits with which kind of application, what kind of blockchain platforms which are available with respect to the various applications that we will see in this entire session. Okay, so I hope my slides are visible, right? Can you please confirm
Yes,
anyone?
visible.
Yeah, thank you. So the
Visible.
consensus is generally we are going to achieve an agreement based on the distributed process, because we all know that blockchain network is a distributed network. So that everybody agree for a single data, single value, so that the until unless once we start the transaction and until unless you reach to the target, the source, from the source to the target, the information whatever we are going to send, that we are going to say that they all the nodes which are going to involve in that particular level are going to reach to a consensus mechanism. So there, so there, what happens is in the network, there are multiple agents which are going to be present in the network. So how to build up a healthy network? Because this network does not contain not only the set of good nodes, even the malicious nodes or attackers, those who are going to be present in the network, and they are going to keep track of the entire information which you are going to send via that particular network. So in that case, how to build a healthy network? So the that is a major question mark. So in order to have a healthy network, we have come up with some kind of agreement among all the nodes which are going to involve. So that is what we are going to say as a consensus mechanism or consensus algorithms. Various algorithms exist. So coming to the Google load balancing, smart grids, that is IoT applications, clock synchronization for the various systems, even our systems, for clock synchronization, and even for the drone control, where these consensus mechanisms are very important. Okay, so these vary from public blockchain to the private blockchain. So there are various kinds of algorithms with the different principles. So before moving to what are the various kinds of algorithms that are existing, so meanwhile, we will go through the objectives of the consensus algorithm. So over here, the main thing is, first one is the agreement seeking. So over here, in order to get into the information, people have to first have to go through the algorithm, and so that all the nodes will be able to agree on that particular uh, agreement. So what is this going to happen is, so next come your collaborator. So all members will be given to join together in order to work together and achieve an particular outcome. So in order to achieve that particular outcome, we are going to have a common agreement in order to achieve it. So cooperative, all the nodes which are present in the network has to cooperate, has to work in a team, leaving their own interest. Okay, they will not have their own interest, they'll keep away their first priority of those interests, and they will work as a team than the individuals. Egalitarian is nothing but each and every node which is present in the network has an equal weight in order to vote from their end. Okay. So over here, there is no higher priority to one node nor the lesser priority for the other node. All are equal. Next comes the inclusive. Inclusive is whichever nodes are involving in the transaction, they are supposed to vote, and they should. There is no such rule, okay, this is like every time we are doing it, let us not do the vote. That is not the way. Actually, whenever you're going to get involved in the transaction and whenever you're going to elect someone as a leader for that particular transaction, then at that particular time this voting system will come into picture. Okay, next comes the participatory. So the consensus will be active where each and every node will be active for the entire process until unless the entire process gets over. Okay, next comes the properties of the consensus. Just now we have seen the objectives, now we are moving towards the properties of the consensus algorithm. These are the main properties of the consensus algorithm. The first one is structural properties. So it is like group-based consensus mechanism algorithm, or it is a election-based mechanism, or in order to have a liveliness within the network, we are going to have a proper structure before we start the consensus mechanism. So, coming to the secure liveness and the tolerance will be calculated using these structural properties. When we go with the security properties, so although we say blockchain is like it provides security as it is a chain process, it consists of hash functions. So all these things, although we say, even it has its own drawbacks. Okay. So what kind of properties has to be adopted in order to overcome that drawbacks that need to be properly analyzed. And if you are going to adopt public blockchain, then the properties are different. If you are going to adopt private blockchain, then the properties for that particular network will be different. If it is a semi, that is nothing but the starting level, it will be private. But the moment it enters into the network, in order to solve the puzzle, if we are allowing all the participants to enter into that particular network in order to solve the transaction, and once the transaction is solved, if they are going to leave, then their properties will be different. Okay, so next comes the performance properties. So what kind of consensus mechanism you are going to adopt, and what is its performance, how it is going to perform. So whether all the nodes which are going to involve in the network are properly performing according to the consensus, according to the agreement which they have agreed when we have started the transaction or communication. You can have, like, you can consider as a transaction or a communication. Sometimes even for normal communication we use blockchain, but with a different purpose. Okay. Sometimes we use for the transactions itself, financial transactions. Generally, transactions I mean to say is financial transactions. Okay. So these are the various consensus algorithms. If you see, then the proof of work, proof of stake, delegated proof of stake, practical Byzantine, fault tolerance, Ripple, Paxos, Raft. So proof of elapsed time, proof of burn, proof of capacity, proof of retrievability, and proof of luck are the various consensus algorithms which are available right now in the blockchain. So that based on your application, what kind of a consensus algorithm you want to adopt, which one suits you best, that you need to find out. And based on that, you need to adopt before you start performing your communication or developing the application. Okay. So we will see all these things step by step in the next coming slides, so that you will go through with I mean you will come to know what are the various things and what kind of applications can be adopted for what kind of consensus mechanisms. Okay, so first comes your proof of work. So what do you mean by proof of work? This was actually published in 1993 by Doc and Moni North, and then they have renamed it and confined it to proof of work in 1999. Okay, so the over here they have used the proof of work concept was used by Bitcoin and Litecoin. Okay, Litecoin is nothing but it is you can even go through this Litecoin concept. Simulator which is available for the IoT. Like for example, Ethereum is available for different purpose, Hyperledger is available for different purpose, Bitcoin is available for different purpose, Litecoin is available for different purposes. Okay, these are the various platforms which are available for various purpose of applications. That anyways we will see in the last slide. So this is how I mean this Litecoin is meant for IoT based applications. Okay, generally it is of lightweight and it will suit. And these coins are nothing but your bitcoins. However, your currency, cryptocurrency, how you are using, same cryptocurrency will be adopted in Litecoin. Okay, so basically the basic concept over here is so over here we are going to have a completed or submitted algorithm, the node which will be obtaining a right to add new transaction to the blockchain. So over here first if I'm the node, I want to start the uh, transaction, then I'll just flood the information saying that I'm going to start a transaction and all the nodes which are active will agree to the consensus. If I say that I'm going to have a puzzle within that particular uh, transaction, then I'm going to reward something so that if the nodes are able to solve that puzzle, then they will get some rewards. Okay, so this is how the general things will go, and the how much complexity the puzzle is, that much more rewards they are going to get. Okay. So the problem, actually, this problem solving will involve the computing power in order to get the proper output. Okay. So proof of work is nothing but like the here the nodes can solve it or they can call the miners to help them, and based on the miner concept. So based on what kind of miners they are getting involved and what kind of the nodes, how much puzzle they have solved, based on that they are going to get the rewards sharing. Okay, so this is about proof of work. The work, how much work you have done, that much rewards you are going to get, in short. So the main characteristics of this is nothing but it is very difficult to solve the mathematical problem. The correctness of the solution has to be verified easily. Then the solution what they obtain can be verified quickly, but it is like not very difficult. I can say it is difficult to solve the mathematical problems. Okay, so they contain the previous hash value, they'll increase their security, and I mean, whoever is going to start the transaction, they'll be creating a puzzle in such a way that the other should not able to decrypt it and they should not get any rewards. If without solving the puzzle, if the target is going to receive the information, then definitely the resources of the nodes will be wasted, but they'll not get any kind of rewards. Okay. And this will solve, like whenever new block is created, the same procedure will be followed. So these are the various advantages and disadvantages of proof of work. Generally, it is depends from the DOS attack. So there is a chance of reduction of DOS attacks on the network, and there is a possibility of mining over the network. And the disadvantages is there is a risk of 51% attack, because if you say that the network is of like semi-based blockchain or it is a public blockchain, then there is a risk of 51% attack, because the basic concept of blockchain is like you are going to adopt the longest chain in order to deliver the information to the target. Okay, so it is a time consuming process because each and every node will try to spend some kind of resources in order to solve that particular puzzle. So it is like a wastage of time. If they solve the puzzle, then they are okay with it, they will get the rewards. But if they don't solve the puzzle, it is a wastage of time. Okay, that is nothing but time consuming. And next one comes the resource consumption. Resource consumption is nothing but like whatever puzzle has to be solved. Meanwhile, the resources are getting, obviously, in order to solve the puzzle, they'll spend their own resources. So that is getting uh, of no use if they are unable to solve, but their resources have been already consumed. Okay. Next comes the transaction confirmation time. There is no particular time. If the TTL value is not fixed for this, then definitely the transaction confirmation time will be more, and useless calculations. If there is a simple this thing also, then we will be having a lot of calculations. Those things are not required. I'm audible, right?
Yes, ma'am, you are audible.
Okay, thank you. So applications of proof of work algorithm are nothing but the first one is your Bitcoin. Next, Bitcoin-based cryptocurrencies such as Litecoin, which is based on similar model, and Ethereum, which is a project of proof of work itself. Now, everybody, the researchers who are into the blockchain are going to adopt, and they are going to test their applications using Ethereum only. Okay. So the proof of work consensus is based on, mainly it is applicable for all kind of blockchain applications. But if it involves some kind of transactions, and if they are specific like this kind of this will not work out, I don't want to have a proof of work, then they move towards the proof of stake. Proof of stake is nothing but the nodes which are going to involve in the network are going to have some coins where he or she going to put it as a stake. They'll keep it as a stake, so that if they say that if I misbehave in the network, then you can have my coins as a interest. Okay. If I solve the puzzle and if I'm genuine in the network, then I will get extra coins. It's like a stock market. You're going to purchase some stocks, okay, and based on that, how you are going to handle them. So if it may be loss, it may be profit for you. Okay. So, but over here, also a slight difference which we are going to see with respect to blockchain of proof of stake consensus is nothing but they are going to validate all the blocks of the transactions, and they hold the Bitcoin or altcoin is the same thing which you have seen in the proof of work. So over here, uh, PP coin is the first cryptocurrency which has been applied for the as a proof of stake to the blockchain. So where the validators will be the miners, instead of just coming into the network and solving the problem, here they validate themselves. The miners will validate themselves, saying that we want to get involved in solving that particular puzzle. Meanwhile, I will. It is like betting process. I'll invest some 10 rupees over there. If I win the puzzle, then I'll get 20 rupees. Else, I will lose my 10 rupees. If I misbehave, but there is no loss, no gain if I'm not going to solve the puzzle in the network. Okay. So that is how things will go. So the if you compare the proof of stake versus proof of work, then it can handle accessibility, centralization, and scalability properly. That is nothing but your proof of stake. Accessibility is nothing but it can have complete access and it can validate all the nodes which have the entry, and they are going to mine that particular network until unless the transaction gets over. Centralization is nothing but it is a decreased entry barriers where you are going to minimize your own cost, and you're going to say that whatever you have, based on that you try to mine that and get to a conclusion. Blockchains will be divided into several set of chains that is called as shard. Okay, which consists of the same process, but until that completion will be taking place, so they will be waiting for that particular result to come across. So these are the advantages of proof of stake and some disadvantages of proof of stake. So it higher speed as compared to proof of work, and it consumes less power because we are not going to use supercomputers there, and like even if your laptop is there, that is more than enough in order to solve the puzzles, and you can sit and do the work. But it is vulnerable to the people, those who are going to invest their money. Okay, sometimes there is a gain, sometimes there is a loss. Okay, so wealthy people get wealthier over here, and the people who does not have money does not get anything. So this is the concept of proof of stake and proof of work. Next, we are moving towards the delegated proof of stake. This is a part of proof of stake only, where users will vote for the and the delegates. Okay, so that over here the nodes will be divided into two parts. One is like as delegate, and one will be the witnesses. Over here, the tokens will be given based on their candidate names, and these tokens are not spent in any way until unless the position or their property remains the same. Okay, so the role is nothing but the role of the witnesses and delegates differ as they will observe and they even abolish the functions of another role. So over here, the witness will able to be present and able to see what is the role of the delegates. Okay, and when they observe the coins and they abolish the functions, and based on that, sometimes the coins will get into stake. The stake, whatever they have put, they'll be in trouble. Okay, so but it is very rare cases because they exchange their rules based on the transactions, whatever they have involved within that particular network. Okay, so it is as I said, same thing has been considered over here. So cryptocurrencies do not allow witnesses to avoid the concurrence of the transactions, and delegates are chosen to oversee the process and to propose the key changes which are going to get involved in the block creation, confirmation, and supervise the criteria such as transaction fees, block sizes, witness pays, and network block intervals. Okay, so these are the various advantages of delegated proof of stake and delegated disadvantages of delegated proof of stake. Nothing but the scalability, speed, energy requirements, defense, decentralization, and egalitarian are some of the advantages of delegated proof of stake. Whereas for the disadvantages, if you see, then the voting in and out of the efficient control. So the panel of witness, sometimes they may behave abnormal and they may leave the block, they may leave the entire network before the transaction completes. At that particular time, it will be very difficult to have a efficient control. Okay. So one more vulnerability is like voting flaws. So if they have small stakes, then obviously they'll not get more votes. And contrast, if they have larger stakes, then they will get more votes. It is like a partiality system. So where they will get larger votes and smaller number of votes based on their stake. Okay. So this systems are susceptible to the centralization as there are small number of witnesses. Again, it leads to the centralized network instead of decentralized network. So practical Byzantine fault tolerance is nothing but it provides a realistic replication of the Byzantine state. What do you mean by Byzantine fault tolerance? Leave about practical Byzantine fault tolerance. What do you mean by Byzantine nodes in the network? So over here, the Byzantine nodes are nothing but the malicious nodes which want to behave maliciously, but they are unable to behave according to their rule. Okay, so these are called as Byzantine nodes. Over here, Byzantine fault tolerance is nothing but some nodes which are actually existing in the network are able to behave maliciously and could able to send the information or make the malicious nodes to enter into the network and perform a 51% attack. So over here, you can say that who is loyal over here in the network. Then how to find out? The nodes which are involved in the network are loyal to each other or not. Okay. So this is not that much possible. So in that case, what we do is we come to a particular consensus mechanism where we will force the Byzantine nodes also to follow those particular rules. Okay, so this is how generally it happens. So this will take place with the help of voting system within the network. If the one third of the votes are more, like compared to the malicious member, then there is no uh, malicious nodes exist in the system. Okay. Else, it is like 51%. I can say the 51% of the nodes, if they are existing, then the network is under attack. If the 51 less than 51% of the nodes are Byzantine nodes, then there is no harm in the network. So this is how the Byzantine fault tolerance works. Over here, the practical Byzantine fault tolerance is nothing but like it is a similar thing, but in the distributed network where the node will be the main or the leader node, and the others are referred as the secondary nodes. Okay. So over here, we are going to apply the majority rule and we are going to find the consensus on the state of the system. So system will operate as long as the maximum number of malicious nodes in the network will occur. Okay. So this is how the practical Byzantine system will work. And this consists of set of rules or I can say operations. So first is to request, second is to pre-prepare, third is to prepare, next comes your commit, and last comes your reply. So request is nothing but transactions are sent to the primary by the user so that they can start the transactions. Once they get the approval, they want to start the transaction. Pre-prepare state is nothing but the proposal, how many transactions they are going to have and what kind of transactions. They are going to prepare it so that they can forward the replicas to all the nodes which are present in the network. Prepare is nothing but once they receive the proposal, the backup has to verify, and if it is success then it will broadcast the prepare messages to all other systems or the nodes which are involving. Okay. So these kind of backups will be helpful only if that verification will fail. Okay. Else it is of no use. The commit is nothing but the 2 by 3rd of the backups will commit the commit messages will allow all this 2 by 3rd of the backups to broadcast by the replicas. So this is like a second round of voting. So if there is any fail or any node has left the network, then this will allow that to have a second round of voting in order to select one more particular leader for the entire transactions. Okay. So reply is nothing but clients will able to see the result of the consensus algorithms. So these are the various advantages, that is energy efficiency, because it will able to know how many are exactly present and how to proceed for that. Okay. So if even if some other nodes are going to leave that particular transaction, they could able to finally know that okay, this has left, again let me conduct one more session. Then it will be easy for them to identify which are active and where the transaction has to reach to the final stage. Okay. Transaction penalty and low reward variance, there is no much reward variance. So whether it is a high level puzzle, low level puzzle, medium level puzzle, based on that the rewards will not vary much from node to node. If they are able to solve the puzzle, they'll able to get the rewards. Else it is zero. Zero or one will not be there. Even the 0.5, 0.75, 0.25. So all these rewards. So there is no much variation in the rewards. Okay. So drawback so is nothing but there is a possibility of civil attacks and there is a possibility of scaling. So Ripple is the next one. So I hope I'm clear with this algorithms. Please let me know if any doubts or anything is there so that I can move further. Yeah, I'll proceed then. So next comes your Ripple. Ripple is nothing but it does not require any kind of mining. It can be accessed by anyone through the web browser. So generally the algorithm consists of the server, ledger, last closed ledger, open ledger, unique node list, and the proposers. So over here, what do you mean by this unique, sorry, so unique node list? So what do you mean by unique node list? Why it is important? So over here, the incoming nodes have a node list, like from where to where, what they have to send, and that is a unique set of list where it knows about the external servers. Only to those servers this nodes will be sent from the this particular source to that particular server. Okay, so over here the servers generally continually receive the transactions from the other servers over the network. So these transactions will be called, these open and closed ledger transactions will able to conclude or to open a new transaction for new transaction ledger for that particular transaction. Okay, so over here each the proposals from the server are not on the UNL. That is nothing but unique node list. So the what is the work of proposers over here? So open ledger, closed ledger, these are okay, fine. We agree that last closed ledger, okay, in order to send the information, if it wants to update, it will able to update. Okay. So open ledger when it has started. So it is, I can say this ripple is nothing but a drop of water which will fall in a still water, then how the ripple will form. So similar fashion, this ripple also will work. So from one server to the other server, in that particular, whichever server is connected to those nodes, it will reflect. Then from that to the next level of servers, so that it can able to check what is a closed ledger and what is a unique ledger at that particular level. And over here, the server will take the transactions which has received at least 50% of the approval uh, for the new proposals. So until unless it receives a 50% of approval from all the nodes which are present in the network, it will not able to proceed further. So that is the reason. So that is the reason server will continuously will able to check the proposals, and it has to send the information to the candidate list until unless the timer will expire. So here the timer will play a major role in order to send the information to the network. And all the nodes which are active or which are passive, that will be checked by the server based on the timer which it is going to send in the network. So once the iterations have been proposed, that is the proposals, new proposals have been accepted with great similarity to each other, then the votes will be increasing in order to agree that particular proposal. And once this proposal has been agreed and the server knows that it has reached to 80% of the consensus has been reached for every transaction in the network, then it is able to say that this is the threshold in order to start the transactions from the next level. So the server will able to validate the proposal or alert the system, so will able to propose the server will validate the proposals, alerts the networks, and close its consensus processes. So until unless it gets a proper validation for that particular proposal, it will not able to send to the network to the next server. And once the proposal is valid, then it is applied to the last closed ledger as a new ledger. It will next, like whatever has been closed, next will be the opening part. So it is like a book, account book. If you see the last will be closed, the next page immediately, next day it will be open. So similar fashion, even people will work. So next comes the Paxos. So what do you mean by Paxos? So now I'll stop here and let us discuss about some of the applications with respect to Ripple, uh, Byzantine, and all these things. Actually, the explanation I've given, but what kind of applications are applicable in order to adopt this kind of consensus mechanism that we have not discussed. So that okay, let me finish Paxos, then I'll 1 second. Let me just check what is the next one. multi-paxos. Okay, I'll do one thing. First paxos, multi-paxos, and raft I'll finish. Then we will move to the next, like what are the various applications which can apply this particular consensus algorithm that we will discuss. Next comes your Paxos. This is a private blockchain based network algorithm. So the consensus of Paxos will be applicable only for the private blockchain. Okay. So where a node will have a highest votes, it broadcasts and says that I'm the winner node and I will take one decision from my end. Okay. So this is nothing but it has a two-phase commit protocol, which will be like prepare phase and the commit phase. Over here, first it has to send the information to all the nodes saying that I want to send some information. It will fetch the votes of that particular all the nodes which are involved in that particular network. Then after that, so they will able to accept or replicate the particular proposals. Then they are going to commit that particular phase. Over here, if I say that if all the nodes are okay with the highest vote, then they are going to broadcast. This process will go on. They commit to the protocol. They prepare, commit phase. Everything is fine. Then what about the failure? So the failure will happen at a prepone phase and the accept phase of the Paxos. Over here, the proposal failure generally happens at the prepone phase, that is before broadcasting. Because whenever you want to prepare the phase, before that you need to broadcast. And when this broadcast fails, the entire network, the proposal will get failed. Because until unless you send it to the nodes, they will not able to reply back, and until unless they commit for that particular transaction commitment, they will not able to get the they'll not able to get the rewards, and this entire process will collapse. So in order to check that, first we need to have one proposal, then the network will wait for some time, then it will send to all the acceptors who are present in the network, so that it will send the information to the network and becomes the network proposal, and then the proposal will be continue to get the information from all the nodes which are present in the network. Okay, so over here the proposal which fails in the accept phase, that is the prepone phase, where the commit proposal will get failed before because of broadcasting failure. Okay, so next comes the accept phase, where the proposal was already having a majority. Then the network will able to accept that particular proposal, but it is unable to finish that particular phase. So prepare phase generally will be having no issue, as there are no other acceptors, because it will just send it and it will able to see that what kind of failure will happen. If at all prepare phase will have a failure, it is only voting case. So it can again flood the information to the network and it can able to achieve it. It's not a big deal. Okay. So, but after proposing, if something gets failed, then it is like n by 2 minus 1 level. Okay. So n is like how many times you have sent, and by 2 minus 1 will be considered in order to end up that particular transaction. Okay. So once it crosses that particular threshold, like n by 2 minus 1 times it has tried and it could not able to succeed, then the proposal with maximum vote, although it has maximum votes, will not able to broadcast it won't count. Okay, although it has maximum, but it won't able to start its transactions. So this is how we are going to have a issue with respect to the Paxos when you adopt, and no one will able to have who is the winner of this particular proposal. So no, I mean, as if there is a failure, so it will not able to know who is the winner for that particular network proposal. Okay, so this is how the commitment will get failed once the transaction gets failed. Okay, so this is the part of the Paxos where the decision will be anonymous decision. So somehow the transaction has to get completed. So in order to finish the transaction, they'll able to go by taking a anonymous decision, because no one has won the proposal, as there is a failure with respect to the broadcast level. That is nothing but prepare phase. Prepone phase has been failed because prepare phase has to send the broadcast information to all the nodes which are active in the network, which got failed within that particular network. Okay, so this is about the Paxos. Then comes your multi-Paxos. So these are the various disadvantages of Paxos. So first one is dueling leaders, and second one is the live lock. Live lock is nothing but sometimes the whatever I have explained you right now. Dual leaders is nothing but there is like because of prepone failure, sometimes they assume that there is no other leader. So let us elect one more leader or let us start one new fresh transaction. At that time, dwelling leaders problem will arise. Next comes your live lock problem. That is nothing but after your acceptance phase where the decision will not be able to be taken and they adopt the malicious decision in the network. Then, in order to overcome the issue of it, they have come up with the multi-paxos, where number of round of paxos will result in a one particular decision. So optimization will be performed at this particular level so that we can assume that single stable leader and skips the prepare phase. And there is no need to continue the sending of the proposals so many times if the leader is always sticky in the network. Okay, so the first proposal number will be sent out will never be overridden because there is only one leader. First thing is we can only send an accept message, and subsequently you can have a number of rounds where the end proposal numbers will be used to originally prepare the request, and additional parameters will indicate the sequence number. That is nothing but the current round which it is going to have. So next comes the raft. Raft is nothing but it is a consensus which has been guided by a leader where a distinguished leader is chosen, and that leader will be entirely responsible for the management of the cluster until unless the transaction gets over. Okay, that particular time one leader is elected and that leader is responsible for the management of that particular cluster. Okay, so this is about the raft consensus. So over here the replicated log will be maintained by the leader through all of the nodes which are comprising the raft cluster. So it performs the leader election, commencing of the election and election procedure, like who has to elect and what is their eligibility, everything will be decided. Then the log replication will be considered. Replication will be prepared so that even if there is any violation with all these rules, like commencing in the convention of the election, or whether a leader is following those rules or not, or the election procedure got deviated or not, those all things will be having a replication of that particular log, and they will try to verify the whoever is going to elect as a leader, they will be responsible and they are going to maintain that particular cluster details. Okay, not like entire network, their cluster. That is nothing but I can say it may be public, it may be private, but that particular cluster details will be maintained accordingly. And safety by default, we should have our entire system to be safe, right? So these are the various advantages of raft, that is ease to understand, ease to implement, and independently approachable for smaller set of problems. Remote procedure calls are enough in order to have your raft. So fairness and availability for the implementation. Okay, Raft is actually a single leader protocol where the traffic in the network can choke the entire system. That is the DOS attack, I can say. So, but not exactly DOS attack, but entire network can get choked by that particular system. Okay, so the variants which can tackle that particular bottleneck. But there are theories where it has been assumed that it will have a non-recurrence of Byzantine errors, that which is going to decrease the applicability of the real-time, more specialized approach of the subset of issues which that may occur when reaching to a consensus in particular. So, yeah, now let us have a small discussion with respect to the applications, with respect to the POW, POS, and delegated proof of stake. So, when you go with the financial transactions, I can say the Hyperledger, what we are going to adopt as a platform, will be by default, it will not consist of any Byzantine nodes, and we are going to go with the delegated proof of stake. Okay. So what kind of algorithm and rest of the applications, whichever there is no financial transactions, and if you feel even if the financial transaction has some value, I mean even if that bitcoins are okay to leave, then we will go with proof of work and all. The Ethereum is based on proof of work, so you can just cross verify with all the protocols, like what kind of platform is based on what kind of consensus mechanism, whichever will suit you, that you can adopt in your entire network. Okay, for your application, for your entire application. Okay, so this is about the set of thing, and I think there is one slide for the applications are there. Okay. Anyways, once I come to this particular slide, I'll discuss about the application. What kind of algorithms are required. Okay. Next comes your proof of elapsed time. What do you mean by elapsed time? Why we require proof of elapsed time? Because if you continuously send out information and the miners or the nodes which are involved in the network are trying to solve the particular person for 24 hours, 42 hours, 48 hours, then where is the sustainability of that particular transaction? Then how to decide that? So it is going to first the participant who is going to involve in that particular network will wait randomly for a time period. Then the first node has to, like, that is the reason the TTL has been introduced into this concept. Okay. So each node in the blockchain network will generate a random wait time and it will go to sleep. So over here, it is not with respect to the transaction. There are two cases over here. So I can say that there are, for example, there are 5 to 10 nodes which are present in the network, and they want to get involved into the transactions. At that particular level, I can say that they could able to see that which are the nodes which are in sleeping state and which are in waiting state. Okay, active. I can say it as a active. Okay. So over here, why we require? Because see, when you have started a transaction, there may be a node which is actually in sleep mode, or they're not even interested to get involved in this particular transaction. At that particular time, who will take this responsibility? How much time I have to spend waiting to agree to make that node active? So that's a big question mark. So for that reason, we will wait randomly. And then if they respond, then they will get involved in the transaction. Else, we will make them to go to sleep mode only. Okay. But over here, let me clear to you. But whenever your transaction is going to start, there you're going to have a majority of the nodes has to get involved in order to approve that particular transaction. Okay. It is not like there are 10 nodes and 6 nodes are in sleepy state and only 4 nodes are active. Then we can proceed with the transaction. So that is not possible. So it is like first one, whoever wants to wake it up first you are going to send a small message. So then it is like, you get up, you're going to get some kind of benefits if you get involved in this particular transaction. Okay. So that is how the process will start. So the same cycle will repeat for a significant time. It is going to wait, and then it will, if the knows, okay, I have finished one particular transaction, but I'm waiting for 4 hours in the same network, but there is no transactions which have happened. then I'm exhausting my resources. Why I should be there in the network? So that is also there. That is two cases over here. Okay. So that is how we are going to consider and we are going to make ensure about that information. So first over here, the system will ensure in order to win, the competing nodes should actually choose a time that is genuinely random and not a shorter period which they are going to be there as a participant in the network. And second is the process need to establish the waiting period which is being met by the winner in the network. Okay. So these are the various advantages. That is, it consumes low power, it has a high resource efficiency, this safety from the external attack because the only private network. Okay. Transparency and cost efficient. Next comes your proof of burn. So what do you mean by proof of burn? So over here, I can say proof of burn is nothing but you're going to invest something, you're not expecting anything. Okay. So it is of useless or inaccessible. Whatever you're going to put into the network, it is not accessible or not, there is no output for that. Okay. So I can say that you are going to burn the coin over there. So over here, you are going to say that burn is nothing, but you're going to some wallet money from which the it won't even come back to you. You're going to invest something. Whereas in proof of stake, whereas in delegated proof of stake, there is a chance for you to get back your money. Okay. But over here in the proof of burn, there is no point in getting back the money. Okay. So over here, the miners where they are going to put their most of the coins and thinking of getting a chance to add to the block on the blockchain so that they will get more rewards in the next level. So this is what the proof of burn says. Generally, they have these addresses which is known as the ether addresses. Okay, so that they randomly the IP addresses you can consider. These are the ether addresses which they generally randomly being associated with any kind of a private key. So over here they can induce the economic scarcity leading to a possibility raise in the value. So that coin burning is another way to make investments in the network security. So these are the various advantages of proof of burn. That is the thing, but increase the sustainability and reduce power consumption. Mining hardware, which is not at all required. Coins will burn using virtual mining rigs only. So miners are encouraged for long-term commitment over here. So it is like you are going to invest, but you are not going to gain anything at that particular time. There may be a loss, there may be a profit, but you will not. I mean, 99%. This is like you are making your own blockchain to construct. Okay, you want to involve and you want to have a longer. I can say for this, I can say the example of your property purchase. So you have something in your hand, you have burned your coins there. Okay, in order to purchase your property, but uh, it is a long-term commitment. Okay. So you can consider that as an example for this proof of burn concept so that you can remember it easily. And disadvantages is it is less transparent, it is of lower speed, it is less eco-friendly and scalability. So next comes your proof of capacity. It consists of two steps. First is the hard drive, which is going to have your repeated data hashing functions, and the miners account, which is treated as a nouns values, which have been generated from 8192 hashes only. Over here, the hashes will be scooped as a pair. So the scoop zero is nothing but it will be having a hash zero and hash one value. Scoop 1 is nothing but hash 2 and hash 3 value. So the hash numbers will start from 0 to 8191. Over here, the entire hashing function will be given as a scoops. Okay. So after once the scoops are ready, then the second stage will include the actual mining process, where the scoop number is measured by the miner who is using it. Okay. So if, for example, if a miner will start the mining operation and produces the scoop number 38, then the miner has to go to the scoop number 38 of nouns 1 and calculate the deadline value using that particular data which has been adopted in that particular scoop. So the method will be repeated until unless the calculations of the deadline in the hard drive will be reached by each nouns. So this kind of hashing function will be applicable for your some kind of confidentiality information where more each and more confident normal information like confidential, not the transaction based confidential information which has to be saved from many people. So company documents and all other they can adopt this proof of capacity. So it consumes less power and it is more fair than the proof of stake due to availability of the cheap or you can say disk can be used, and it is more eco-friendly and energy efficient, and it uses the Bitcoin cryptocurrencies ASCII based mining. Okay, and there is no need of any specialized hardware from the user side. Only the system or laptops or the mobiles can be used for their proof of capacity based blockchain network. Okay, so data from mining can be quickly wiped off, and I can say that. Tuffle is the one of the application which is going to adopt the proof of capacity. So it is being used in order to develop the Android-based blockchain application. Okay. So next comes your disadvantages. The system will has not been adopted by many because of experience, lack of experienced people, and a competition to produce higher capacity hard drives will arise in the future in order to have the adoption of proof of capacity algorithm. These are the various applications. Space Mint, Perma, Coin, and Burst coins are the various applications of the proof of capacity. And next comes your proof of retrievability. So it is like proofing on a remote host, that is nothing but the peer. It actually issues and verifies the file which has been given on a remote host. Okay, this is like a challenge response relationship where you can say the challenge is called as a audit and the heartbeat is called as a response for that particular challenge. Okay. So the owner will check the host of the integrity and then the availability data. Then they are going to store that particular file and which network they want to store, and entire thing will be stored in terms of a encoded way. Okay, so whenever I can say the owner, if the owner will forget the response, okay, the challenge which has been issued at one point, I can in general I can say this, a file which you have stored in the locker and the locker key if you lost, then there is no point. Even if you go back to the bank and if you want to open that particular file, there is no use until unless your locker key has to be there with you. So this is like they are checking your integrity in order to say that you are the correct person in order to open that particular locker. Okay, same process will happen for the proof of retrievability in the blockchain. So if you adopt proof of retrievability, then there is a challenge and response relationship where you're going to identify or you're going to justify that you are the same person or the client to check the integrity of that particular uh, transaction or a file or a network, whichever, wherever you are going to involve. Okay. Next comes your proof of luck. I guess this is the last consensus algorithm where the all the participants will commit to all the uncommitted transactions by forming a new block and a numeric value. Then they give according to the version block. Okay. Election will be performed but where all the participants will randomly vote, and whoever gets the highest vote, they are the winner. Okay, so that is the luckiest block, I can say, or luckiest person in the network who is going to start the transaction and who is going to have a next block of the chain in terms of ledger. So as soon as they obtain the luckiest block, to minimize the network congestion, other participants will quit the mining and they broadcast. It is like I don't have any profit in the network, then why I should stay at this particular layer? Then let me quit and let me join to the other network where I can solve some puzzles and I can get some kind of information or some kind of rewards from that particular network. So that is how they'll quit this particular block and they will shift to the other block. So that is nothing but you can say that whichever is lucky, they'll get more profit in the shares, and whoever is not lucky, they'll get less profit in the shares. So these are the various advantages of the proof of work. So the confirmation of the transactions is very fast and deterministic, and the protocol is efficient in terms of energy and network communication. It is resistant to custom hardware, and it is not commonly available. So blockchain cannot be controlled by the attacker, controlling under threshold of TEEs, and TEEs is nothing but a platform breaching the TEE platforms. So over here, the attacker will not able to have any control with respect to the blockchain. So the synchronized block will be is not required between the participants, because whenever they want to get into the network, they can come into the network. Proof of luck, they can become the elected person within that particular network, and they can able to uh, visit that particular network, and they can leave the particular network whenever they are they are willing to. Okay, this is about the consensus algorithms with respect to the blockchain. So out of this 12 to 14 consensus algorithms are existing, 14 I guess, yeah. So in this entire network, so the blockchain will adopt only this 14 consensus algorithms. Okay. So whichever wants to adopt any kind of the consensus, what kind of transactions they want to do, based on that only they are going to adopt this particular consensus algorithm. Okay, and these are the supporting platforms based on those consensus mechanisms. So these are the various platforms where those are by default they adopt those consensus mechanisms, varying from platform to platform. So these are the various, you can even have a check like for what kind of applications you want this kind of platform, which will suit for what purpose, that you need to verify before you adopt the blockchain platform. That is nothing but first platform is Bitcoin, Ethereum, Hyperledger, Open Blockchain, Bluemix, Litecoin, List, Quorum, HDAC, Eris, Tendermint. So over here, Ethereum, generally we all use Hyperledger, which is being adopted for the finance application. IBM Open Blockchain is meant for the IBM-based applications. Litecoin, it is for IoT. List, Quorum, HDAC, Eris, Tendermint. So these are the various things meant for various kind of applications. Okay. So if you adopt this kind of thing, then you can develop this kind of applications, I can say, or rather I can say, if you want to develop this kind of application, those platforms which suit, and those for those platforms which kind of blockchain consensus mechanism suits. So it is like reverse engineering. You can go in a forward engineering process so that you will understand what kind of algorithm has been adopted for what kind of uh, simulation environment, or I can say the platform bitcoin blockchain platform, and then what kind of application you are going to develop. Okay, so over here the application, various applications are nothing but digital currency, which is going to adopt the bitcoin, smart contract, Ethereum, internet of healthcare. These healthcare, if it is IoT based, then in that case, I can say Litecoin. If it is normal healthcare, then it can adopt Ethereum. Okay, so that's the reason that nothing is written there. Hyperledger, financial transactions, smart city energy consumption. This is with respect to your IoT applications, government elections, identity management, intellectual property protection. autonomous decentralized peer-to-peer telemetry. So for drone-based applications also they started adopting this blockchain. So IoT in 5G era, Internet of Vehicles, things, devices, access management, collaborative video delivery, cloud storage, intrusion detection, software design networking, fog computing, distributed peer-to-peer applications, crowd sensing application, data storage. Even the insurance network was the first. iGang is the first one which has adopted this blockchain technology for the insurance. Okay, so to verify whether that person is genuine or not, and how it can able to get this input and output properly, so that it can that insurance amount will go to the genuine person only, and there is no force, okay, forgery, or there is no false information which has been given by the people. Generally that happens, right? So tracking of the IoT assets was the first MyBit company which has come forward in order to track the IoT assets. And Aero token was the first one for the real-time navigation drones. So the you fly your drone only in this particular range. So if you have to pay some bitcoins to that particular thing. So this is like real-time navigation, where the Aero token was the first company which has come forward in order to adopt the blockchain for that. Smart payments, identity, government services, waste management are some of the applications. If you see, even the Karnataka government has blockchain for the land revenue system, even for the Telangana government has blockchain for the property, maintaining of the properties and all other stuff using blockchain. Okay, so I can say that in conclusion, we have covered the various algorithms and significance of the blockchain with advantages and disadvantages for various blockchain applications, and algorithm has to be chosen based on the best fit for the application and its use cases. So this is like I'm back with my session conclusion. Now I'm open for uh, discussion for a small period of time. So I'm open for discussion. So no doubts. So shall I start asking doubts? Priyanshi, Priyanshi ma'am, are you there?
Yes, ma'am.
Yeah,
Yes, ma'am.
ma'am. Yeah, ma'am. I guess there are no doubts, I guess. So my
Yes,
session
yes,
was
ma'am.
like very bored, or it was interesting. I don't know. Then in that case, whether people
Yeah.
have got something into, I mean, some understanding for that, or whether they did not understand anything, I'm out of information. Yes, ma'am. Savita, ma'am. Uh,
Hello.
yes,
Am I audible, ma'am?
yes, yes. You're audible, ma'am.
Okay, ma'am. I want to ask you a question that regarding POW.
Okay.
Okay. In that miners need to reach the difficulty level, right?
Hmm.
So how we can decide the difficulty level?
No, that will be decided by the person who is going to start the transaction.
Okay.
Actually,
So
the
miner.
point is, for example, I'll tell you, I want to send a
Yeah.
information, financial information
Yeah.
from, so how many participants are there? 36 participants are there, including myself. Okay. But I
Okay.
want to
Okay.
send
Fine.
information from me to you. But I need to actually, amount is very less. For
Yeah.
example, 10 rupees or 15 rupees, it does not matter much. Even if that
Okay.
information is known to the other nodes also, for me, it does not matter. But I should
Okay.
make sure that all the nodes who are going to involve in this particular transaction should
Yeah.
update their ledger with minus 15 rupees from my end and plus 15 rupees from your end.
Yeah, okay,
Okay.
fine.
And
Yeah,
at this particular level, it's not a large amount, right? When I'm
yeah,
going
right.
to start the transaction, so at that particular time, I'll just, in order to verify, just I'll give a small low level of puzzle,
Okay,
some mathematical puzzle. Okay, a plus b equals to
okay,
a plus b whole square equals to so and so. Instead of
okay,
what a value is 5 and b value is 5. Okay,
okay.
so once they
Yeah,
come out with the output as 15, for example, I'm not giving exact values, I'm just taking an example. Okay,
yeah,
so if they
okay,
if the
fine.
output is 15, whenever this puzzle will go to from node 1 to the next
Okay,
node, next node, next node, until it reaches you, all the
yeah,
people who were involved, they have exhausted some resources. Okay, and
right, right.
they have to update their ledger with the same
Yeah,
thing. So if the
yes, ma'am.
puzzle level is very low, actually there is no gain, no loss for them. Okay.
Right, right,
So
right.
and I
Yes,
have put that those who have solved a plus b whole square equals to so and so, and the output
yeah,
should be 15. Okay. And those who
yeah.
have solved that, okay, out of 15 rupees in order to send to you, I'll put 1 rupee for the reward.
Okay,
Okay, and
okay, ma'am.
in that situation, how many people have solved that particular puzzle? I mean, it won't be that much a small puzzle in the network, but
Hmm.
I'm just taking an example so that you will able to understand. Okay, so when
Okay,
whoever have solved the puzzle, this 1 rupee will be given to them, divided.
okay,
How many people have answered? So based on, so if a person has solved a plus b equals to a square plus b square plus so and so, but he could not able to retrieve the answer as 15, but he knows the formula, then he will get
okay,
little higher, I mean little less compared to the person who has solved the puzzle and who has got the
right.
exact answer. Okay,
Okay,
so
huh.
in this case, whenever we are going to like it completely depends on what kind of puzzle. If I want to send 1 lakh to you, and I don't
Okay,
want everybody along with that, I'm sending some valuable documents to you.
okay.
Okay, then in that
Yes,
case, my puzzle level has to be very, very high.
right, right, right.
So in order to fix that puzzle, I'll fix the rewards also. I'll say that those whoever will solve this particular puzzle will get some $10 for the entire scenario.
Okay,
If I say have 1 lakh dollars, I have to send it to you, and the some important documents I have to send it to you, then in that particular case, I will say that okay, whoever will solve some $50, I'm going to give it in the network. So equally division among the minors. Okay.
okay,
So
okay,
based
okay,
on
okay.
that, we are going to decide. No one is over here. No one is the leader. No one is the centralized node. So
Yeah, right,
whoever
right.
is going to start the process, they will be the person who will decide the puzzle level. They will be the person who wants to first. They will uh, broadcast the information that I want to start the transaction.
Yeah,
Once they get
okay.
the reply from how many nodes are active, based on that, then that person will able to frame the puzzle and send it to the network. I hope I have answered your question.
Yeah, yeah, yeah. Yes, ma'am. Yes, thank you. Getting.
Yeah,
Thank you, ma'am.
yeah, thank you.
Ma'am,
Yes.
uh, is the blockchain supply chain really transparent?
Hmm?
Is there really transparency in the supply chain of blockchain?
No, you're combining two different things. Supply chain is different and blockchain is different. What you want to say?
See, what I want to ask is blockchain. How does blockchain enhance the supply chain's transparency?
Supply chain transparency, it is you will get the information. No, all the ledgers wherever it is going to go. If you take the supply chain management, so if you are
Yes.
sending something from, for example, I'm in Suratkal. From here, you are sending something to Mangalore. So how many stops
Yes.
the vehicle has stopped? That will be tracked back, right? The IoT devices, so it will alert even if it is it got stopped in different place, then definitely it will get the alert to the genuine user. No, actually, I'm not sure what question you have asked because these are two different questions. Are you asking about supply chain management application related blockchain based work? or it is a different concept which you are expecting? I did not get that question.
I was asking about the if we see about Bitcoin or any other cryptocurrency.
Okay.
So when we transact between two Bitcoins, you
Hmm.
know, sender and receiver.
Okay.
So will that be tracked or not in
Sender
the
and
supply chain?
it will be. It will be tracked. It will
Okay.
be tracked by default because all the ledgers will, whichever are involved, they'll get updated, right? It will be
Yes.
tracked.
Yes.
Yeah. That is the concept of transparency,
Okay.
right?
Yes.
Whenever
Yes,
you
ma'am.
want to track, you can able to see.
Yes, ma'am.
Okay.
With due respect, ma'am, can we end the session or
Hmm.
someone want to add something?
If anybody has questions, it's fine. Else, we can end up the session.
Okay, okay, ma'am.
Okay. Uh, can I have some feedbacks from the participants so that I can also improve myself in terms of explanation, in terms of if you have any suggestions with respect to the talk? Anyone? I guess no one. Okay, Vishal, thank you. Thanks for the
So,
opportunity.
okay. A heartfelt thank you to Dr. Bhavana Rudra for sharing your valuable insights today. The participants truly got inspired a lot from the dedication, your achievements, and presentation serve as a true inspiration. We thank all participants for your engagement. In closing, let's carry forward the spirit of learning and innovation inspired by today's session. Thank you, Dr. Rudra, and all attendees for joining this mesmerizing session. Thank you so much.
Thank you. Thanks for inviting. Thank you.
Thank you, ma'am.
Can we get the presentation, ma'am?
I'll mail. I'll mail to ma'am. Okay.
Okay, thank you so much, ma'am.
Priyanshi ma'am, I'll just mail to her. Okay.
Yeah,
Okay.
yes, ma'am.
Thank you
Thank
so
you.
much.
Thank you so much, ma'am.